Chapter 10, 11.6, and example 1 on page 13. So far, we've just discussed equations of conic sections in their rectangular form. Some conic sections can also be described parametrically. So notice these come in pairs. We have an x equals and a y equals, where t is between -2 and 2. Identify the curve by finding the corresponding rectangular equation. So what we are doing is we're plugging in -2 literally for t in the top one and then the bottom one. -2 plus 1 is -1. If I plug into the bottom, -2 squared is 4. 4 minus 4 is 0. Plus or minus 0 is just 0. Then I would plug -1 to the top. I get 0. If I plug in -1 on the bottom, I get plus or minus √3. If I plug in 0 up top for t, I get 1. If I plug in 0 on the bottom, I get plus or minus square root of 4, which is plus or minus 2. If I plug 1 in up top for t, I get 2. If I plug in 1 on the bottom, I get plus or minus √3. If I plug in 2 up top, I get 3. On the bottom, plus or minus square root of 0 or 0. So if I plot these points, I'll graph the corresponding parametric equation. Here's -1, 0. Here is 0 plus or minus √3, like up approximately 1.7 and down 1.7. 1 plus or minus 2, so 1 comma 2, 1 -2, 2 comma √3, 2 comma -√3, and then 3, 0. And if I connect these, what's going to happen is I'm going to get a circle like this. And basically in this circle, if we can look at this, the center is 1, 0. And the radius, if we look, is 2. So this is a parametric equation. If people remember a rectangular equation for a circle in general, it looks like this. And if we plug in 1 and 0 for h and k and 2 for r, we would get this equation, which would look like this. So this would be the rectangular equation, parametric equation in terms of 3 variables, looks like that. Okay, second one, find the rectangular equation of the curve whose parametric equations where t is between 0 and 180. So I'm going to make a table t, x, and y, and I'm going to plug in values between 0 and 180. I'll go by 30, and these are degrees. So what we are doing is we're carefully in our calculator, because that might help, plugging in 0 for t up top and on the bottom, and then 30 and 60 and so forth. So if we plug in, I got -1, 0. If I plug in 30, I get -0.866.25. If I plug in 60 up top for t, I get -0.5. If I plug 60 in on the bottom, I get 0.75. 90 up top for t, I get 0. If I plug in the bottom, I get 1. If I plug in 120 up top, I get 1/2. On the bottom, I get 0.75. If I plug in 150 up top, I get 0.866. If I plug in the bottom, I get 0.25. And if I plug in 180 up top, I get 1. And on the bottom, I get 0. So if I plot these points, here's 0. I'm going to space this out. Let's see, here's -1, here's 1. And if I'm going by a quarter just to plot these a little better. So here's -1, 0, -0.866 and a quarter, -1/2, and then up 0.75, 0, 1. So it's going this way, 0.5 and 0.75, 0.866 and up a quarter, and then 1, 0. So if we use arrows, it's going in this direction, like this. And a trig identity we did earlier this year was cosine squared plus sine squared equals 1. And what's going to happen here, if we substitute in, this is y, negative cosine t times negative cosine t is cosine squared. So this is really x squared plus y equals 1. So we're just really graphing this parabola. 1 minus x squared, or negative x squared plus 1. So this is a parabola. And then the last one, find the parametric equations for this rectangular equation. We're going to utilize this identity. Once again, cosine squared t plus sine squared t equals 1. And what I can say is this. I'm going to just set the first part equal to cosine squared t. So I'm going to set cosine squared t equal to x squared over 9. And what I can do is this. So cosine squared plus sine squared equals 1. So if cosine squared equals x squared over 9, if I square root each side, I can say cosine t equals x over 3. So this is really, I can write this as x over 3 squared. There's just another way to write this. And this is really just rewriting this. And then here, sine squared t equals y squared over 4. If you square root each side, sine t is y over 2. So it's y over 2 squared. Okay, but the goal here is to write this in terms of parametric equations. So that's like up top where we have an x and a y equals equation. So if this is the relationship between cosine of t equals x over 3 and sine of t equals y over 2, if I put this over 1, I could just cross multiply and then I'll have two parametric equations. So here I have x equals 3 cosine t. And then here, if I put this over 1 and cross multiply, I have y equals 2 sine t. Like this. These are the parametric equations. If I went to graph this, if I plugged in values like if like some points that would work here, if x was 3, y would be 0. If x is negative 3, y is also 0. We're just finding like sort of the intercepts here. If x is 0, y is 2, or negative 2. So the graph of this actually would be an ellipse here, if we graph this. So this graph, when graphed, is an ellipse. Where the last one was a parabola and the first one was a circle. Okay, so these are the notes from page 13 from section 10.6 on parametric equations.